typical IT environment where we understand the working of IT industry looks as per the diagram. So when we receive a client requirement in a software company or an IT services company, what first happens is a business analyst, usually someone who is from management who understands functionalities, and the person may be from finance, commerce, banking, or automobile sectors, depending on what the client is. All of the software or IT companies have experts who understand the businesses, like how a bank functions is known to a banking expert, and the banking expert becomes business analyst there. And if it is an automobile industry, an automobile expert becomes a business analyst. And these business analysts have nothing to do with the technical understanding of programming, usually speaking. And these go to the client and they jot down all the requirements. And what could be the requirements here is so understood that way that could be something that may be to do with if the client is a Walmart, then they want an e-commerce application like Amazon, and they may ask an IT company. So somebody who then is a commerce expert who understands how the supermarket working functions will begin jotting down. And that is the main work of a business analyst. BA jots down that client requirements. And then BA presents the client requirements to the IT team. So this is the work of the BA, or business analyst usually called BA. And in a typical IT service or services company, this is the usual scenario. Now, when the client requirement is so presented in terms of maybe wireframes that people talk about, or PPT presentations, and the client may even want a very typical GUI that has certain fields, and all of those specific requirements are also so jotted down, including how the software applications the GUI must look like. And these are all given by business analyst back to the IT team. Now the IT team may be in India, the client company may be in the US. And the first job is what we then call is the requirements. In SDLC, this is usually called requirements phase, or in software development lifecycle phase, this is usually called requirements. Business requirements are all jotted down. And once this work is over, so the actual work of the software application that begins then. In other words, the architects of the team will get all of these requirements, and they begin understanding then how could we actually materialize the needs, or the needs of the clients to a software application. So a team of architects may be comprising of design architect who then designs the GUI, or a graphical user interface, or he may design the entire system. And then a typical architect that may be something to do with very infrastructure architect. Infrastructure architect is someone who decides how many servers this software application may need, that is needed by the client, and what type of CPUs, what type of memory, storage, what type of servers, and do they need data center, do they need a cloud, and should it be storage intensive, computing intensive? In other words, does it have a lot of calculations? If it turns out to be Amazon Web Services, Azure, Oracle Cloud, if it is turning out to be cloud, what is to choose with respect to infrastructure is decided by the infrastructure architect. And then it is to do with the database architect. And the database architect designs database schemas, tables, does data modeling, then establishes the entity relationship, diagrams, and also he has a say to the infrastructure team or the design team on the choice of database vendors, what would be better, if it is Oracle, if it is SQL Server, PostgreSQL, MySQL, and also based on the client needs, if they can fund for Oracle and expense what we then call as CAPEX, capital expenditure, that is also considered in all of these phases where architect team comes out with a complete design, choosing the right software. If the client cannot fund more or is having a sort of a limited budget, then there may be uh, choices of open source softwares that can be or perhaps used like databases, PostgreSQL or PHP, and others that where the client says they just want a pure open source sort of software application, and they don't have much of the requirements where they want Java or .NET. That is still payment based itself, as they still have to pay for a certain amount for buying out their JDK or JRE, and commercial licenses cost every time. And then it is to do with the design, where IT applications architect begins designing with high level design, low level design, and then when architect team decides yes it can be completed and they are very confident, then they update the client company, and a small sort of a prototype of how it works is so-called POC, or in other words, POC, or proof of concept of software application, like sample module, like software, like application is present to the client to show or to prove the capacity of the IT team to deliver, not just on time, but to deliver as well what they then need. And once this is over, they begin the actual development. So development will have its own test cases and the unit tests. When the developers begin and they finish in different phases, the code from the development gets pushed to the test environment. And here, the test specialist will begin testing. Maybe it may be something to do with testing that could be functional of all of those functionalities that are so covered by the business analysts, is it so present in the software applications is all in a test environment that we see. And once the test team certifies, yes, everything is there, and then it may be moved to UAT, or upon successful certification that everything certainly works with the sample data that is in the test that resembles the production systems, then it may be even moved to production. And there will be two phases in production. One is called a dry run. Dry run is where there is still a backup of whatever they then do, the client. And parallelly, one production system begins running to know on a load that is not as heavy as the business as usual or everyday load. And they test it once on production, but we do not, or they do not call it live. And if there is any problem there, not just with the code, but with the connections, with the network, and many other infrastructures that are all related to the client infrastructure, that is also resolved with the dry run phase. And once the dry run phase is successful, the team plans installation of all of it on production, and they make it live. So when it is live, it's as good as say the software application is delivered to the client. This is the complete understanding of how it works as an SDLC life cycle, and uh, in a very generic to know now what is so that is the difference between the front end and the backend team. When all of them are developers, but what is so important here that we then understand if there is no full stack here, that the team has a front end team and a back end team, especially that is with the development. Then the main difference is front end is all mostly to do with programming team that does Java or PHP or GUI, and backend team is very typical, is mostly to do with database development. If there is any team, or else both are done, or both are taken care by full stack programmers, or what we then call, who then take care of the front end and back end, including everything from scratch to the delivery. That these types of developers are usually independent programmers, or module programmers, or senior programmers, who then complete the whole of the chunk of programming, including Java, including the database, and if it turns out to be Oracle, then it may be something to do with PL/SQL procedures. If it is SQL Server, then T-SQL, and it could be Postgres, SQLs, PGP, PG. It is procedural language, something to do with Postgres SQL, as PGPL SQL, I believe, or PLPG SQL. And MySQL also has a programming interface with different types of vendors of database. In other words, that I'm actually trying to explain. So this is about how the IT industry looks like, and we also see how the code looks like. So this is a typical code that is a PHP code here. So these programs are usually stored in application servers, and application servers may look like Apache, WebLogic, GlassFish in case of Java, and the programming logic of database is not existing here, but it exists in the server, that is the database server itself. Now, these are backend code like Oracle PL/SQL, SQL servers, T-SQL, and the logic, what we then write, is so divided between the Java in case of Java, Java programming, with Java as well as Oracle PL/SQL, and with PHP as well, with databases that may be to do with Oracle and PL/SQL, or SQL Server, then T-SQL. In this typical example, where a PHP program file, a chunk of code or a part of code that is so taken looks like this. And what it is doing, it is creating a connection. Now, the front-end team, in other words, the PHP programmers will write this in development, and they get a driver. A driver software is nothing but a way to connect to the database, a software that helps to connect the front end to the database. And it has typical procedures, or if it is connections through drivers, then we use certain functions of drivers to use it. That way that we configure certain uh, variables. So these are those variables where database name, database user, database password, and connections are all entered, and the name of the service instance, including port numbers, and then a connection is initiated. And this is how it looks like. And it is always the same. The conventions that are so used, where we then may have a bind variable or a variable that is so passed on the fly that may not be hard coded, just like what is so seen here, as this is a pure small and a very simple example of learning how to create a connection. And this is connection to the database. And there are different ways, including creating a connection using the PDO driver. In case of PHP data object PDO. So we also see an example where we invoke a stored procedure. And this was of importance to us, as we will be able to appreciate where we see something that is the front end and also the back end, and the back end team that involves in programming this very procedure. In this example, my stored procedure, and from the front end or from the PHP, we create a connection and we then connect. And here we are invoking the stored procedure. And this is the call to the stored procedure with a name, my stored procedure, with parameters, two parameters that are name and age that are passed, that goes to the SQL server. And there is one return variable that you see here is a count that is returned back from the SQL server. Like T-SQL, this my stored procedure is very similar. Like PL/SQL, this T-SQL also is. There is a little change in the syntax and way we program, but it remains almost the same. And typical understanding is where this my stored procedure is programmed by the backend team. Now, if there is a difference where we have a difference between front-end team and back-end team, this one thing is written typically. I say typically as full stack people write all of it all together. And after the backend team writes the stored procedure, and on the basis of after the compilation, the backend team gives how to actually execute this stored procedure to the front end team, and the developers of the front end team will test this my stored procedure by passing those parameters or variables, and it may be the very simple way like this as well, what you see in this diagram. And this is how the main difference between a front end and a back end team that can be appreciated with both doing programming. And this milestone procedure, why is it better? And why backend team is needed? In this case, that all of the programs that can be run from the front end team does not need any backend team if we are speaking about queries that could be all executed from the front end. This question is usually asked many times by many people, and the simple answer is 100,000 connection that happens. If it is 100,000 connections that are needed from the front end, like what we then observe in this example of creating a connection and a query that is a simple one, that is select star from table is there. So typically 100,000 connections are created here. What is the advantage of server-side code inside the database itself, where a block or a chunk is so fast at one go and does all the work? That is where the backend team or the developers, who are usually called PL/SQL developers or T-SQL developers, are paid well at the same time. And what we see here is this my stored procedure that does lot of things inside, maybe something to do with calculations, but it is all with just one single connection. It's just one create a connection, you see here, and it is very similar. Just one connection, and the whole of this my stored procedure block is called, and it is a compiled object stored inside the database. Or it's as good as saying this stored procedure is really compiled and stored once, and it need not be compiled again and again. And that helps in quick executions and faster as well, reducing the network bandwidth at the same time with just a single connection when the chunk of block just gets all of whatever is needed. In this case, name and age is passed and out parameters is discount. So this is how we can really appreciate the development team and its way of working in a very typical environment that may be something to do with a big banking enterprise. And such banking enterprise really rely more on data and more on back-end team with database development, as most of those that are database intensive operations are always better to be in database and programmed using the database constructs itself that finishes and completes basics of the IT industry and the difference between the front end, back end developers and the usual very typical code that we see. Thank you.